Hello and welcome to this demo. Today we are going to be going through Hyperledger Fabric, access-based control. Access-based control is an access-based policy control method whereby attributes are what are given consideration other than just roles. And some of the attributes in this case would be the environment attributes, the object, which is the user attributes, the data that is the item being transacted in this system, and the environment that the user would be in, and the properties of the data that these users are trying to get access to or to transact through the network. And so basically, access-based control is a more granular method to handle access control policies, where attributes would be the core of the access control, other than just using roles as, say, admin 1, admin 2. It just builds up on top of that and creates something greater, I can say. So in this demo, we're going to see how access-based control would be implemented in the case of Hyperledger Fabric blockchain. Hyperledger Fabric is a permissioned blockchain which serves a very good use case for enterprises, as it allows for the safeguarding of private data, allows for the creation of channels, thus the separation of concerns, and is also quite scalable and very a bit more versatile than the Ethereum or Polygon or Hedera blockchains would be in an enterprise use case. This gives more control to a user or to an organization than you would have with the likes of Ethereum. Why? This is because you basically bring up your own blockchain network, but building upon this open source framework that is Hyperledger Fabric, that is developed by the Linux Foundation. So that's Hyperledger Fabric, and that's what we're going to be using to showcase how access-based control would be implemented. And for the code, yes, please have a look at my GitHub. Yes, my GitHub should properly showcase you where the code is and how to run it. But I'll do a simple run through on how everything would potentially work in this case. And so yeah, let's dive right through it. Yes, first things first, we are going to open the code base. The code base, I will use VS Code for this to open the code base. As you can see, I have opened the POC HLF ABAC folder. I have cloned this on my local machine, and that's what I'm using. So we're going to dive right straight into it. And the first thing we see when we land into our application is the README. It highlights how to basically run, have the system up and running. Yeah, basically that's what we're going to do. So first things first, let me just first take you through different modules or different services that exist in our network. So the first thing is the scripts. For the sake of this demo, I have opted to write custom scripts that I use to bring up the network, deploy the network, set up the whole network, in a whole, it also simulates the process of enrollment and registration of a user. That is done here. So the setup here helps us install the fabric and set up the testnet and start it. The deploy helps us obviously deploy the chain code. You can deploy the chain code through the normal way, or you can deploy the chain code as a service. Basically, that's really up to you. But since we have not built these in the service yet, we are going to just deploy it in the normal way. And this here is our chain code, or rather our smart contract. Basically, these two terms are used interchangeably in the Hyperledger Fabric environment, but the chain code is what encompasses different smart contracts that handle different business logic that is geared towards a certain functionality or yeah, a certain use case in the system. So for these, we have one smart contract, which is the ABAC smart contract. It is written in Go, and this does basic CRUD operations, and that is what we are going to be showcasing in this tutorial. Basic CRUD operations. Yeah, and from here we export the smart contract and expose it to be packaged in a way that can be consumed on the network. Then from there we have the gateway, our point of interaction with the smart contract, and this is just our backend, which we're going to use to simulate the creation of an asset, the updating of an asset, the transfer, the deletion, and the getting of all assets. I've also added some functions to showcase how events would be handled in this instance, but that we're not going to use for now. For now, we're just going to simulate the scenario whereby one user, or rather, there would be many users in the system, and these users would basically be trying to access different parts of the data in the system. And for that, we're going to start by clearing the script, and we're going to run the testnet, set up the test network, and yeah, let's wait for that. Yeah, so what basically is happening here, the first thing that our system is doing is first we install Fabric. Okay, we really don't have to do this every single time, but since this is the first time we are running this together, we opt to just do all this. So we install Fabric, and for that we install the Docker containers, the binary files, and the Fabric samples present here. And then from there, we are going to set up the testnet. Basically, we would extract the test network from the Fabric samples and then remove the Fabric samples folder. And this is basically just a script that helps us bring up the test network easier for us. There are other ways to do this. We could opt to bring up the test network as a Kubernetes cluster. We could opt to bring up the test network as a service, or we could use the PowerShell, but for simplicity, we opt to use this. And then from there, we start the test network. And this would basically mean first check if there's bring down any Fabric network that is running, and then create a channel while bringing up the network. And yeah, we're using CouchDB for this as our state database for the world states. Yes. And then after that, we are going to simply just deploy this to my channel. As you can see, child is created and joined, and we're done configuring the Hyperledger Fabric test network. And then now we are going to deploy this. Yes. So basically, the same thing that happens on other public blockchains, for instance, the Ethereum network, is we mostly are trying to put, or rather add business logic to a blockchain. And how do we do that? We add business logic to a blockchain via smart contracts, and for you to interact with the smart contract on the blockchain, it has to be on the blockchain peers, and that's what we call deploying. That's what we're doing. And as you can see, Hyperledger Fabric has a different way at which transactions move from one user to another, and that interaction is handled by organization of peers in the network, that some act as the endorsers, others act as the committers, others act as the verifiers. But basically, yeah, that is how Hyperledger Fabric works. And yeah, as you can see, we're done committing to my channel, and then we are waiting for the deployment to finish. After which we are going to simulate the creation of a user. And yeah, as you can see, the deployment is done. And now let's simulate the creation of a user. And we're going to use the simulate script. And for this, I'm going to create a first user as our user, and yeah, that is done successfully. Now, from there, now we can go to our backend and to the connect go file. You see here there is these are the configs for the user, and we want to act as the first user. And while acting as the first user, we want to create an asset. And for that, we're going to create an asset. Basically, all we're doing is we are creating an asset that has an asset ID of timestamp plus asset, concatenation of the asset, the string asset, and the timestamp of now. And yeah, basically that's what we're going to do for simplicity and for the sake of this demo. And so yes, we're going to create an asset, and then we're going to list all the assets. So first things first, let's run this Go application, and for that we use Go run and period. And as you can see, we've created our first asset of asset ID fish, and as you can see, the certificate name, the X509 certificate, that is what is used as our client ID. He's the first user. Let's do one more and create at least 2 for each user. And while at it, let's create second user here. Create the second user. Yes, and we are going to change the user to the second user. Yes, second user. And we're going to create 2 assets for the same as well. Yes, that's asset for the second user, asset 1 for the second user, and asset 2 for the second user. Good, that is done. As you can see, now we have 4 assets. Yes, so basically, what we do when we are creating an asset is we call the function create asset on the smart contract that issues a new asset to the world state with the details that we pass. We pass the ID, which is the string, the color, the size, and the appraised value. So, as you can see here, creating an asset requires an asset. It requires that the asset has an attribute called ABAC creator, and the user who is submitting this transaction should have this attribute. ABAC creator is equals to true, and if not, they are not allowed to create the asset. So this is where all this happens. So basically, when we are registering a user, when we are simulating the registration of a user, we are assigning an attribute that is about the creator is equals to true and as an insert, and that is the attribute that we are checking here. That's the this table we are checking for just one attribute, and that is the attribute now that we are checking in this instance, and we are checking whether a user has the attribute creator. If this user did not have the attribute creator, we could not be able to create an asset because he doesn't have the attribute of creator. And also, it is important to note that if the user does not own the asset, if the user is not the creator of this asset, so let's see here when we create the asset, we assign the owner as the client ID. The owner field here is assigned as the client ID is what is assigned to the owner field. So every time we're trying to delete or update or transfer or basically do any evaluation transaction, do any transaction that affects the world state, then it is required that the user be the owner of that data. And also remember, this user had to have the attribute of creator. Remember that you can choose not to include such an attribute to a user when creating one, and basically these attributes would separate various users, various levels of users, simply by means of if a user is not a creator, then they cannot create an asset. They cannot actually even edit the asset. They can only basically just view the asset. And furthermore, we're going to test one thing. We're going to test if the user can actually, let's say, update the asset. Yeah, let's update the assets. And we're going to take the first asset, obviously. And now let's do something more easier. Yeah, we're going to take the last asset, and we're going to simulate that. Yes, we're going to simulate that and use that as the asset ID. Remember, the user that's connected here is the second user. That's why we've gone for the last asset. And what we're trying to do is we are trying to update this. So first, let me change to the first user. Yes, first user. And we're going to run this. Basically, this should not work. This should fail. As you can see, that has failed. We were trying to update the appraised value to 200 from 100, but that has failed because the first user is not the owner of these data. Is not the owner of these assets. So that's why that's failed. If we change these back to the second user, yes, the second user, these should basically work. Yes, As you can see, the asset has been updated successfully because now the right user is the one that's connected to the system that's we're using that user certificate and key to connect to the system in this instance. Let's try and see if we'll find a different user from the ones we have here. Yes, one user. Yeah, let's try. Let's try and see what user one would do in this system. Let's try and see. First of all, if we try to update this, it's going to fail miserably. Yes, that has failed, as you can see. So yeah, he has no authority to update this, and also his user cannot actually create anything. Yes, the user cannot create anything because as if you remember, when we were creating our user here using this simulate, we were basically adding an attribute, but this was created by the system when we were bringing up the Fabric client and the Fabric certificate authority, and this was created. This would in this instance be a user who has viewed who is on the system but doesn't have the attributes ABAC creator, and that would mean that this user cannot do anything because he fails to have a certain attribute that is required for him to make computations or make changes to the system or even simply just view. Yes. Yeah, I think that's it for now. If in case of anything, in case of any issues, please feel free to open an issue on GitHub, and yeah, I'll check it out when I can, and I think that's it for now. Thank you.